For the following examples, factor the polynomial. And it says here some of the polynomials may not have a common factor. For number 17, 3x plus 3. It is a binomial, two terms. We have the term 3x, we have the term 3. So we could go off to the side of our board and list each of these terms separately. And we could use our prime factorization techniques that we've seen thus far. Some of us may want to just keep it as the polynomial. But either way, the same result applies here. Let's think about factoring 3x. Well, let's start with the number 3. Can we factor 3? 3 is prime. So x here is one factor. So this is just simply a factor of 3 and a factor of x. That's it. We could write it as a polynomial x plus x plus x, but that's not simplified. X plus x plus x is 3x, where our factors are 3 and x. What about 3? 3 is prime. It's just simply 3 times 1. 3 times 1 is 3. What factor or factors are the same or common for each of the terms here? It's 3. Our GCF for our two terms is 3. So how do we use this GCF to factor out of our polynomial? Well, we start by listing our GCF first. So here we will list the factor of 3 because that's our greatest common factor for our two terms, 3. We will now use parentheses to indicate that this factor, which again factors multiply, this 3 is now going to multiply whatever terms we leave behind. For the 3x here, if we factor or if we remove that 3 from 3x, what do we leave behind? If this 3 gets eliminated, we leave behind simply a factor of x. For our second term here, the positive 3, if we factor out the GCF of 3, if this factor of 3 gets moved out, what do we leave behind? Simply the factor 1. So this plus 3 here, when a 3 gets factored out, we leave behind a positive 1, resulting in a factorization of 3 and x plus 1. What are the factors for our binomial 3x plus 3? The factors are 3 and x plus 1. The product of our monomial GCF, our one-termed number here, our greatest common factor, and x plus 1. We can confirm this by using our distributive property. 3 multiply x. As we see, 3 times x we write as 3x. 3 multiply this positive 1. As we see, 3 times 1 will give us a positive 3. This is the same exact expression that we started with, which confirms that we successfully factored and wrote the correct binomial factor of x plus 1. 24y squared minus 18. Factor the polynomial. Anytime we factor a polynomial, the first thing we want to ask ourselves is there a greatest common factor? We start by looking at each term in our polynomial. Here we have 2, making this a binomial. We can either list out each of the terms and go from there using prime factorization, or we can leave it in the polynomial form, but at the end of the day, we have to write it in the polynomial form because it's saying factor the polynomial. We need to get a result that is some factor multiply some factor, whatever those factors are. That is how we factor a polynomial. You need to write out each of these factors multiplying together. That is factoring. Let's start by factoring the 24y squared. 24 is 8 times 3. 8 is not a prime number. We have seen before that 8 is 4 times 2, but 4 is 2 times 2. So 8 is 2 cubed. or 2 times 2 times 2. Y squared indicates two factors of y. We have a minus sign here. Now what about factorizing 18? 18 is 6 times 3. 6 is 2 times 3. So 18, when we prime factorize it, 2 times 3 times 3. Of course, we can check that. 3 times 3 is 9, times 2 is 18. 2 times 3 is 6, times 3 is 18. Right, so just for fun here, this is just listing each term according to their factors. We could have taken this and just done it over here, but I'm having fun with it and putting it in the polynomial form. Because now as we grab these common factors and move them out front, we can visualize how we leave behind the remaining factors. Here, here. Common factor of 2. I have these two factors of 2 over here, but there are no more over here. So there are no more common factors of 2. Common factor of 3 in each. But I have this factor of 3 over here, and I have no more over here. So I'm done with the factors of 3. I have these two factors of y over here, but I have no factors of y over here. So there is no common factor of y. So what are my common factors? 2 and 3. My common factors are 2 and 3. Factors multiply. 2 times 3 is 6. It should make sense that for a polynomial to have a GCF of 6, right? This polynomial has a variable involved. Shouldn't the variable be in the GCF? One of your terms in this polynomial, this term here, minus 18, does not have the variable y in it at all. Therefore, the variable y, it cannot be in the GCF because the variable y is not a factor in this term here. What is the greatest common factor, or what is the largest number that will divide into 24y squared and 18 as well? It's 6. 6, 12, 18. 6, 12, 18, 24. So we factor out a 6. Anytime we factor, introduce parentheses because we must determine what we leave behind. That is our resulting factor. That's the other thing, the other number or expression that will multiply our 6. So what is that expression? Well, this 6 here was from this 2 and 3. The factors we left behind for our first term, 24y squared, 2 times 2 times y times y. 2 times 2 is 4. Y times y. Y squared. Minus 2 times 3 here. That was our 6 that we factored out. So what did we leave behind here? A factor of 3. So the product of 6 and 4y squared minus 3 will give us our binomial 24y squared minus 18. Always, we can confirm that with multiplication using the distributive property. GCF of 6, multiply our first term. 6 times 4 times y squared is 24y squared. 6 times negative 3 is negative 18. 100 plus 75z minus 50z squared. Factor the polynomial. Let's first start by looking for the greatest common factor for each of our 3 terms. In some of these cases, you might want to go, and again, I strongly encourage you every single time, if you need to go off to the side, write each of these terms separately and use prime factorization. Rewrite 10 as its product of prime factors, 10 times 10, where 10 is 2 times 5. 2 times 2 times 5 times 5 is 100. But beyond that, we can start looking at the fact that when you start collecting common factors, you will then need to multiply together those common factors to get your greatest common factor. To think ahead on that, what is the largest number that will divide into 100, 75, and 50? When are these numbers useful to us in real life? I have 25 cents, so I have a quarter. I have 50 cents, I have 75 cents, or I have 100 cents, which is $1. So 25 can divide into each of these, because we just expressed that. 25 times 1, 25 times 2, 25 times 3, 25 times 4. And 25 is the largest such number that will divide into 100, 75, and 50. So I'm going to divide out or factor out 25. But what about this variable of z here? I have one factor of z here. I have two factors of z here. I have no factors of z here. So I cannot factor out the variable z because it is not present in this term. It must be present in each of the terms that are in our polynomial. So our greatest common factor is 25 because it is the largest number that will divide into all three terms. Once we factor out that GCF to the front, introduce parentheses to determine what we leave behind. In other words, if you factor a 25 out of 100, what do I need to multiply to 25 to get back to 100? In other words, 100 divided by 25 is 4. 4 quarters and $1. Plus 25 times what will give us 75z? Well, 25 times 3 plus this additional factor of z. 25 times 3z, 75z. Minus 25 times 2 with our additional two factors of z. As we see here, 25 times negative 2 is negative 50 times z squared is negative 50 z squared. So our GCF is 25, and the product of 25 and the resulting trinomial, 4 plus 3z minus 2z squared, will give us our original trinomial expression. 9x to the fourth power plus 6x cubed plus 18x squared. Factor the polynomial. Each of these three terms here contains the variable x. X squared is multiplying 18, x cubed is multiplying 6, x to the fourth is multiplying 9. So these are factors. I have 4 factors here of x, 3 factors of x here, 2 factors of x here. How many factors of x is common for each of the three terms? Well, I have 4 here, but I don't have 4 here and here. I have 3 here. I have 3 plus 1 here. I don't have 3 over here. I have 2 here. I have 2 plus 1 here. And I have 2 plus 2 factors of x here. So I do have a common 2 factors of x. So we know that we can factor out x squared now. But what else can we factor out? What about the numbers 9, 6, and 18? Is there a number that can divide into 9, 6, and 18? And is it the largest such number? Because what about 9? 9 will divide into 9 one time. 9 will divide into 18 twice. 9 cannot divide into 6. Okay, what about the number 6? 6 divides into 6 one time. 6 divides into 18 3 times. 6 divides into 9 1, but there's a remainder. It does not divide fully. We want to work with integers. We want to have these whole numbers to work with. Maybe it's a number smaller than the ones listed. What do we know here? What numbers look like this? Well, these numbers are even, so we could factor out a 2, but 9 is not an even number. We cannot factor out a 2. What about 3? It's the next number after 2. 3, 6, 9, 12, 15, 18. So with 9, 6, and 18, the largest such number to factor out is 3. So the greatest common factor for our trinomial expression is the 3x squared. Because 3x squared can actually be pulled out or factored out of each of these three terms. And it's the largest such factor that can be factored out. So it's the GCF. So what do we need to multiply to our GCF in order to get back our three terms? In other words, 9x to the fourth divided out or factored out to 3x squared. 9 divided by 3 is 3. X to the fourth divided by x squared, well, 4 minus 2 is 2. So we leave behind two factors of x. But that makes sense, right? If I take out or if I factor out two of the four factors, I had to leave behind the other two factors. Plus, if I have a 6, which is 2 times 3, and I pull out that 3, I'll leave behind the factor of 2. That's because 6 divided by 3 is 2. I have 3 factors, but out of those 3, I took 2 of them and moved them to the front. I left behind one factor. 3 minus 2 is one factor of x. Plus 18, which is 2 times 9, 6 times 3. It's 2 times 3 times 3. But one of those 3's just got moved out front with your GCF. So 2 times 3 times 3 is now 2 times 3, which is 6. Oh, 3 times 6, that's 18. I had that x squared factor, but it got moved out front. So I have no more factors of x present for this term here, because the x squared is in the front of my expression now. Of course, this can be confirmed by distributing. GCF multiply the first term, GCF multiply the second, GCF multiply the third. Simplifying each of those three products will give you your original trinomial expression. So we have two factors. We have the, well, you can list out more. You have 3 x, x. So we have two factors of x here. And then we have the trinomial 3x squared plus 2x plus 6. This last objective, factoring by grouping, there are occasions when the common factor, as we've seen in a previous slide, where the factor of an expression is not simply a monomial or one number or one variable or the product. For instance, the expression x squared multiply x minus 2 plus 3 multiply x minus 2 actually contains a binomial factor for each term. Thus, our common binomial factor, x minus 2, is our greatest common factor. Factoring out the x minus 2 and introducing parentheses, what do we leave behind when we factor out the x minus 2? For our first term, we leave behind the x squared. For our second term, we leave behind the 3. So the resulting polynomial that we have left behind there is x squared plus 3, indicating that for our expression, we have two factors, the factor x minus 2 and the factor x squared plus 3. So this type of factoring is part of a more general procedure called factoring by grouping. This is especially important for us because when we move into our next few sections, factoring trinomials, we will consider factoring trinomials as a form of grouping method. Very important that we nail down this topic here. For the following exercise, factor the polynomial by grouping. Number 63, we have the product of y and q minus 5. Subtract 10, multiply q minus 5. Similarly to the example we saw before, y is multiplying q minus 5, making y and q minus 5 the two factors for our first term. For the second term, 10 is multiplying q minus 5, making 10 and q minus 5 the two factors for the second term. For those two terms, do we have factors that are common for each? We see that q minus 5 is common for each of the two terms. So we begin our factoring by taking the common factor, the greatest common factor of q minus 5, and moving it out front. When we factor out the q minus 5, what do we leave behind here? For the first term, we have simply the y. And for the second term, we have the 10, separated by a minus sign. So that's minus 10. Thus, the product of our binomial factors, q minus 5 and y minus 10, this will give us the original expression that we began with, y multiply q minus 5, subtract 10, multiply q minus 5. So factoring by grouping is going to give us a way to rewrite our expressions, and in our next section it will be a trinomial. It will give us a chance to rewrite our trinomial expression as a factoring by grouping. X squared plus 3x plus 4x plus 12. We have a polynomial with 4 terms. But the thing we notice here is that 3x plus 4x is unsimplified. We can combine 3x and 4x to get 7x. But notice here, it's not telling us to simplify our expression. It's telling us to factor, and more specifically, factor by grouping. To factor by grouping, we want to consider binomial common factors. For 63, it was very obvious our binomial factor, q minus 5. But for 71, it looks a little bit different here. We are given 4 terms. Our first question is there a greatest common factor throughout our 4 terms? The first 3 terms contain the variable x. The 4th term does not. So the factor of x cannot be a part of our greatest common factor. Looking at the numbers, for x squared, we have the coefficient 1. For our last terms, 3, 4, and 12, if you look at the coefficients of 1, 3, 4, and 12, because the number 1 is involved, the greatest common factor is simply 1. That does not help factor out our 4-termed polynomial. So what we want to do here is consider our factoring by grouping. To factor by grouping, you will look to factor a greatest common factor out of the first 2 terms and the last 2 terms separately. In other words, for number 71, we will group together our first 2 terms, x squared plus 3x. We will group together our second 2 terms, 4x plus 12. Because again, for each of these 4 terms, there is not a GCF for the collection. We break this down, x times x, 3 times x, 2 times 2 times x, 2 times 2 times 3. There is not a single factor that is common for each. It's just the factor of 1. A GCF of 1 does not help us simplify down, so there has to be another method. There has to be another mean. For this, factor by grouping. There are 4 terms. Group together the first 2, group together the last 2, and let's see what we can do here. For x squared plus 3x, our greatest common factor, or the largest such thing that we can move out, is x. Why is that the case? There's our prime factorization, as simple as that. For 4x, once you get used to this, you don't have to do this every time. That's the beautiful thing about mathematics and algebra. Establish the pattern. This world is built with patterns, algorithms and patterns. Repeat, repeat, repeat. Same thing here. X is common for these 2 terms, so we know we can factor out an x, but how many? There's 1 common factor of x for these 2 terms. When you factor out the common factor of x, or in this case, our greatest common factor, what do you leave behind? For this first term, you leave behind an x, our plus sign. And for our second term, when this x gets moved out front, we leave behind a 3. For these terms here, so we have this plus sign. Go ahead and just bring that down to common factors for these 2 terms. We have 2 factors of 2 common, which is just 4. Now what do we leave behind here? An x and a 3. Well, wouldn't you know it, look at this. We have rewritten our 4-termed polynomial as the expression x multiply x plus 3, which of course if I Distribute back through, x times x is x squared. X times 3 is 3x. 4 times x is 4x. 4 times 3 is 12. So now my new expression here, x multiply x plus 3 plus 4 multiply x plus 3. I have two factors here, x and x plus 3. I have the factors 4 and x plus 3. What's common? X plus 3 is common. We have a common binomial factor, x plus 3. So we move it out front. When we factor by the greatest common factor, introduce parentheses to determine what you leave behind. This x plus 3 gets moved out, and we leave behind a single factor of x. This x plus 3 gets factored out, leaving us behind the plus 4. And as we will see here, according to our FOIL method, if we ran through the FOIL method, multiply these binomial factors, x plus 3, x plus 4, you're right back up here. Product of the first terms, x times x, is x squared. Product of the outside terms, x times 4, well, that's a positive 4x. Product of the inside terms, 3 and x, is a positive 3x. Product of the last terms, 3 times 4 is 12. So we're going to see here that this is all part of our steps in order to correctly factor our trinomials in the next few sections. 8x squared plus 32x plus x plus 4. We have a polynomial with 4 terms. The last term, 4, does not contain a factor of x. Therefore, the factor of x cannot be a part of our greatest common factor. Looking at the coefficients of 8, 32, 1, and 4, the greatest common factor between those 4 numbers, 8, 32, 1, and 4, is 1. The GCF of any set of numbers that includes the number 1 will always be 1. So for number 79, our GCF is 1. That's not going to help us here for factoring the polynomial. However, we do have 4 terms, so we will look to group together the first 2. We will group together the last 2, and we will try to determine if there is a common binomial factor that is hidden within this polynomial expression. Grouping the first 2 and last 2. 8x squared plus 32x. What is our GCF here? In other words, what is our largest such monomial that can divide into these 2? Well, let's look at 8 and 32. What's the largest number that will divide into 8 as well as 32? Well, 8 and 32 are both even, so we know that 2 can go into 8, and we know that 2 can go into 32. But is that the largest number that will divide into 8 and 32? 4, right? 4 will divide into 8 twice. 4 will divide into 32 8 times. But is that the largest number that will divide into 8 and 32? What about the number 6? Right? 6 can't divide into 8, so it can't be that. What about the number 8? 8 goes into 8 once. 8 divided by 8 is 1. How many times will 8 go into 32? 8, 16, 24, 32. So 8 is actually the largest number that will divide 8 and 32. So we will factor out an 8. But each term also has the x. X squared, x to the first power. Well, I don't have 2 factors of x over here. However, I do have a factor of x in each of these terms, so that's what's common. So those first 2 terms, I have a GCF of 8x, but what do I leave behind? 8x multiply what gives me 8x squared? Just an x. 8x times x is 8x squared. What do I need to multiply to 8x to get 32x? I'll write my plus sign here. And now 32 divided by 8, 8, 16, 24, 32, that's 4. Now the 32x divided by 8x, well, this factor of x here, it's right there. So there are no other factors of x for this second term, and that's it. I have 8 multiply x plus 4, and that will give us back the 8x squared plus 32x. Moving to our second set of terms, x plus 4. Keep in mind the coefficient for x is 1. The coefficient tells you how many x's you have. How many x's? I have 1x. I don't have 5 x's. I don't have 10 x's. I have 1x. 1x plus 4. So what is our GCF for these 2 terms? I can't factor out an x. There is not a factor of x present. So we're looking at the 1 and the 4. The GCF for 1 and 4, 1. So I factor out the GCF of 1. If I factor out a 1, what do I leave behind? Factoring is the reverse of multiplication, so it's sort of like dividing. If you divide by 1, do you change anything? 10 divided by 1 is 10. 4 divided by 1 is 4. So here, 1x divided by 1 is simply 1x. So we'll write down x. If I have 4 and I factor out a 1, well, 4 is 1 times 4. I factor out a 1, it stays 4. And of course, that 4 is positive. Notice what happened here. And this is not by coincidence, this is by design. Grouping these two together, now, of course, it might be possible that we can't factor by grouping, but as we will see leading into the next few sections, that in order to successfully factor a trinomial, this will happen every single time. When you factor by grouping, you will always end up with these binomials being exactly the same. That is because now we see this polynomial with 4 terms does not have a common monomial factor. It does, however, have a common binomial factor. And it just so happens to be the greatest common binomial factor. So the x plus 4 is multiplying 8x. The x plus 4 is multiplying 1. So we factor out the x plus 4. Anytime you factor out the GCF, introduce parentheses to determine what you leave behind. We leave behind 8x plus 1. And once more, the product of these two binomials, this is the factorization. The prime factorization, as long as we cannot further factor these two binomials, this is the prime factorization for our polynomial here. We can always confirm this by multiplying. Product of first terms, x times 8x is 8x squared. Product of our outside terms here, x times 1 is 1x. Product of inside terms, 4 times 8x, 32x. Product of last terms, 4 times 1, gives us 4. T cubed minus 3t squared plus 2t minus 6. Factor the polynomial by grouping. We'll first ask ourselves, is there a greatest common monomial factor? Looking at all 4 terms, can we factor out a GCF? Once again, noting the last term, negative 6, does not contain a factor of t. Therefore, we cannot factor out the variable t. So what about the coefficients? 1, negative 3, 2, negative 6. Because we have a coefficient of 1, again, that indicates that a GCF is 1. Can't do anything about it. We'll factor by grouping. In other words, we will group together the first 2 terms, and we'll group together the last 2 terms. For the first 2 terms, do we have a greatest common factor? T cubed, 3t squared. The variable t is present for each, so we know we can factor out the variable t, but how many factors of t can we pull out? There are 3 here, there are 2 here. So we can factor out 2 factors of t. This coefficient is understood to be 1. And if we look at 1 and 3, they're both prime numbers, and the GCF between 1 and 3 is 1. So this is 1t squared, or simply t squared. Factoring t squared out of t cubed, what do we leave behind? Here's 2 factors, here's 3. I'll leave behind 1 factor of t. Minus sign. 3t squared, but I factored out t squared. So if I factor or I remove the t squared out of the term, I'll leave behind minus 3. So moving over here to our second terms, our second binomial, the 2t minus 6 deal, when we determine a GCF for these 2 terms, keep in mind that whatever you leave behind, you want it to match whatever this binomial is. Whatever we leave behind over here, we want this binomial to be exactly t minus 3. But let's see what the GCF gives us here. 2t minus 6. Let's look at first off, this 6 here does not have a variable t, so we cannot factor out a t. So we're looking at 2 and 6. They're both even numbers, so we can factor out a 2, and that's actually the largest GCF. 2 times 1 is 2. 2, 4, 6, so 2 times 3 is 6. 2t, if I factor out the 2, or I remove that factor of 2, I leave behind simply the factor of t. A minus sign, 6 divided by 2 is 3. And so as we see, if we needed to check ourselves as we go along, what's nice about this is that as you move from step to step, check your work to see that if it lines up with what you previously had. T squared times t is t cubed. T squared times negative 3, or negative 3 times t squared is negative 3t squared. A positive 2 times t is 2t. Positive 2 times negative 3 is negative 6. For our two terms here, there is a common binomial factor of t minus 3. When we factor out our GCF of t minus 3, notice for our four terms, there is not a common monomial factor, but if we factor by grouping, we expose a common binomial factor. So our GCF for this polynomial is the binomial t minus 3. What do we leave behind? We introduce parentheses that will determine our additional factor that multiplies our GCF to give us the original polynomial. T squared plus 2. The product of these two binomials will give us our resulting four-termed polynomial. We can check using the FOIL method here. T times t squared is in fact t cubed. T times a positive 2 is a positive 2t. Negative 3 times t squared is negative 3t squared. Negative 3 times positive 2 is negative 6.